Good morning, good afternoon, good evening, whatever time you're watching. I am Pauline Margaret F. Parish from Group 3 and here to present the quadratic function. Do you play basketball or volleyball? Of course, who doesn't? Did you know that basketball and volleyball are related to quadratic function? Quadratic function is applicable to everyday life. Quadratic function is defined as f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. It can also be in the form of y is equal to ax squared plus bx plus c, which is the standard form. I have a couple of examples here of quadratic functions, which are f of x is equal to 3x squared plus 8x minus 5, f of x is equal to x squared minus 6x, and f of x is equal to negative 4x plus 7. Now, I have a few students who are here to present a few knowledge about the quadratic function.
Hi, I'm your student teacher for today, and now we're going to talk about the minimum or maximum value of quadratic function, where the vertex form of the quadratic function is equal to y is equal to a times x minus h squared plus k, which is h is equal to negative b over 2a and k is equal to 4ac minus b squared over 4a. In the quadratic function, either in standard form or vertex form, you can determine if it has a minimum or maximum value. A quadratic function has a minimum value if a is greater than 0, and a quadratic function has a maximum value if a is less than 0. Now, I'm going to show you my solution. Here's my solution. I already expressed it in the form of y is equal to a x minus h and identify the minimum or maximum value. Now, I'm gonna group x squared plus bx. Next, I'm gonna factor out the common factor and add and subtract a real number that makes the next expression in the parentheses a perfect square trinomial or PST. Now, I already expressed the PST as a square of binomial. A is greater than 0, then the quadratic function has the minimum value, and it is negative 7 at x is equal to 2.
Guys, I'm your teacher for the third day of quadratic function. This time, I will teach you how to get the domain and the range of quadratic function. But before anything else, what is range? The range of a function, the set of all real values of y that you can get by plugging real numbers into x. And what is domain? The domain of a function is the set of all real numbers that will give real values for y. Before getting the range, let us transform the quadratic function into a vertex form. Group x squared plus bx. Next, factor out the common factor, then add and subtract a real number that makes the next expression in the parentheses a perfect square trinomial. And next, I will get the simplified form of the perfect square trinomial. Get the range. This is the A. So, negative 2 is less than 0. So, we will follow the second rule. Y is less than or equal to 3. And this is the range of the quadratic function negative 2x squared minus 4x plus 1.
Hey guys, I'm your teacher in 4th day. Today, I discuss how to get the vertex and the line of symmetry of an equation. So here is one of the example of it. F of x equals to negative 3x squared plus 8. First, analyze the equation. Think of a number that can satisfy to x. And for me, I think it's negative 2. So, substitute it. F of x equals to negative 3, negative 2 squared plus 8. So, f of x equals to negative 3 plus times 4 plus 8. And f of x equals to negative 4. So, in first, x is equals to negative 2 and y equals to negative 4. After finding the x and y, graph it into a Cartesian plane. First, negative 2 and negative 4. So, it is this. And next, negative 1 and 5. And the third is 0, 8, which is the x is equals to the line of symmetry. The next, positive 1 and 5. And the last, positive 2 and negative 4. So, in the rules of the parabola, the A is equals to negative 3 so that it is open downward. And combining all of the points. And lastly, the vertex of it equation is 0 and 8.
Guys, I am Madrid Nardakis and I am your student teacher for the lesson Zeros of Quadratic Function. Before anything else, what is zeros of quadratic function? Zeros of quadratic function are the intersections of the parabola to the x-axis of the coordinate plane. The zeros of the quadratic function can be obtained by replacing y or f of x with 0. For the quadratic function, ax squared plus bx plus c equals 0, then solve for x using any convenient method discussed in chapter 1. If the quadratic function is in the form of y equals a quantity x minus h squared plus k, then express it in the form of y equals ax squared plus bx plus c before replacing y by 0. The examples, the number one example is y equals 2x squared minus 3x minus 5. In y equals 2x squared minus 3x minus 5, replace y with 0. 2x squared minus 3x minus 5 equals 0. Then, use a convenient method run lesson. Then, it comes out with 2x, quantity 2x minus 5 times quantity x plus 1 equals 0. Then, x equals 5 over 2 or x equals negative 1, and therefore, these are the zeros of the function. So the result 5 over 2 and negative 1 are plotted into the Cartesian plane. So here is the negative 1 and here is the 5 over 2. And because the a is greater than 0 in the equation y equals 2x squared, 2 is the a, so the opening of the parabola is upward. In the second problem, determine the quadratic function f of x whose zeros are 2 times positive negative square root of 3. So the solution, applying the sum and product of the roots, which is the easier in this case, 2 plus square root of 3 plus 2 minus square root of 3 equals 4 because you can cancel the positive 3 and the negative 3. So 2 plus 2 equals 4. In getting the sum of the roots, quantity 2 plus square root of 3 times quantity 2 minus square root of 3 equals 1. So therefore, the quadratic function is f of x equals x squared minus 4x plus 1. In the third case, the table is given with the values x and y, where x are negative 1, 0, 1, 2, and 3. And the y's are 12, 3, 2, 9, and 24. For the easier case, using 0, 0, 3, 1, 2, and 2, 9. For 0, 3, 3 is equals to c. While for 1, 2, 2 equals a times the quantity 1 squared plus b. For 1, 2, substitute the 1 for the x and 2 for the y. 2 equals a quantity 1 squared plus b times 1 plus 3. So 2 equals a plus b plus 3. Then transpose negative 1 equals a plus b. For 2, 9, substitute 2 for x and 9 for y, where 9 equals a times the quantity 2 squared plus b times the quantity 2 plus 3, where 9 equals 4a plus 2b, and 6 equals 4a plus 2b, or 3 equals 2a plus b. So now we go to subtracting the second equation from the first equation. 3 equals 2a plus b is the second equation, and negative 1 equals a plus b is the first equation. So, subtracting 3 minus negative 1, the answer is 4. So, 4 is the 8. Solving for b, negative 1 equals 4 plus b. So, negative 5 is the b. Therefore, f of x equals 4x squared minus 5x plus 3.
Equals to 0. Height is equals to 0. So, negative 16t squared plus 20t plus 50. So, I will simplify it and divide it by negative 2. T squared minus 10t minus 25. So, I will use the quadratic formula. Negative b plus or minus square root of b squared minus 4ac over 2a. So, negative b, negative 10 times negative is equals to positive 10. So, 10 plus or minus square root of negative 10 squared is equals to 100. So, 100. So, minus 4AC. A is equals to 8. So, 8 times 4 is equals to negative 32 times C, negative 25. So, equals to 900. So, plus 900 over 2A. 2 times 8 is equals to 16. So, here we go. 10 plus or minus square root of 900 is equals to 30 over 2 times A. 2 times 8 is equals to 16. 10. So, I will use first the addition operation. Plus 30 over 16. 40 over 16. Or 5 over 2. Next, 80 t squared minus 20 minus 10 rather t minus 25. So, I will substitute 5 over 2 to t squared. 8 over 8 times 5 over 2 squared minus 10. 5 over 2 equals 25. So, square of 5 square of 5 over 2 is 25 over 4. So, 25 over 4 times 8 minus 50. Negative 50 over 2 is negative 25. So, negative 25 equals 25. 25 times 8 is equals to 200 divided by 4 is equals to 50. 50 minus 25 is equals to 25. So, 25 is equal to 25. So, our answer is correct.